Hello and welcome to the Werkzeug Introduction screencast. My name is Armin Ronacher and I will show you how to create a wiki in 30 minutes using Werkzeug, Jinja 2, SQL Alchemy and Creole Parser. In this screencast I am using virtualenv to keep track of the libraries installed just for this project. You don't have to do it this way, but it allows you to use multiple library versions for different projects. Okay, so let's get started. First we create a folder and bootstrap a virtual environment in this folder. Now we can activate it and install our libraries. So while it's installing, we can fire up our editor and create a file that's used to start a local development server. We call it startserver.py. The contents of this file are pretty simple. We import from Werkzeug run simple, from wiki.app our application, and then we call run simple on localhost port 5000. We give it the application and we say we want to use the debugger and we want to use the automatic code reloading. Now we can go back to our shell and create an empty package. We call it wiki and we touch an empty init.py file in it. Now we can create our wiki app.py file, where we just implement a small hello world application just to check if the server works. We import from Werkzeug request and response, and we create an application using request.application as decorator, and in this application we return a response object that says hello world. If we now switch back to our shell, we can start the server and we have the application running on localhost port 5000 and the reloader is working. So if the code changes, the server will reload. And of course on localhost port 5000 we can see hello world. Now we can start working on the database. For this we create a new file called database.db, where we import from datum class and from SQL Alchemy a couple of helper classes and connection functions. We will use these to create our schema directly in this Python model, and we can then automatically create the schema in the database based on this information. Now we create a new connection to our database. In SQL Alchemy, connections are represented as engines and they connect to a database URI that represents the database. And in this case we directly connect to wiki.database in the same folder. And we want to convert Unicode, which means that every text data we send through the wire is actually Unicode. And what's really important here is that we are hard coding the path to the database. That's not so clever, but it's okay for testing purposes. Then we have to create the metadata and the session. And here we say we want a scoped session, which means every thread has its own session. And we create the session against the database engine. In this model have autoflush enabled and autocommat set to false. Then we can create our database tables. Here we say we want a page table with page ID and name. And then we also create a revision table where we store the actual revision information. What's important for the page ID is that this is a foreign key to the other table. Then the only other thing we need in the revision table is the timestamp, which is the date of the change, and of course the text, and we also add a change note which allows the user to enter a small summary for this change. Now we can create the database tables using SQL Alchemy, but before we do this, we create the classes which are mapped against the tables so that we can easily access the information in the database and create new. So we create a new revision class which takes the page, the title, the text, the change note, and the timestamp. If the timestamp is not provided, we will use the current one, which is UTC now. Note that we are using UTC dates internally. And then we can assign it to the class, and SQL Alchemy will take care of the rest. And then we can do the same thing for the page. Then we can tell SQL Alchemy how it should map the classes against the tables. For this we will use session.mapper. We give it the class first and then the table it should map against. And this works fine for revision. It's a little bit more complicated for the page, because the page is not only mapped against the page table, but also has a property which is the list of all revisions for this page. So we say it's a property revisions, which is a dynamic loader, and it points to the revision class, and there's a back reference called page, which means that a specific revision object then has an attribute called page, which points to the page. And then we give it a default order, which means order by revision ID in descending order. Now we can open a Python shell and import from wiki.database the database engine and metadata, and use the createAll method to create the tables. Whoops, there is a typo. It should be session with 2s. Okay, and then we can use metadata createAll database engine. And if we look at the database using SQLite 3, we can see that the schema was created properly. The next thing we have to do is to implement the actions. Basically, each wiki page has 3 actions: show, edit, and log. The first one, show, displays the page; edit modifies or creates it; and log displays a revision log. We put these into a new file called actions.py inside our package. The first one which we create is the show action, and for testing purposes we just put our simple hello from the page name in it. And we have to import the request response object so that it works. And then we import from our wiki actions a dict called all actions, which we have to create here, where we give it the action name, for example show, and the reference to the function which should be executed. And then we can change our application to a simple dispatching mechanism. And for this we have to import the HTTP exception base class and the not found exception from the Werkzeug model, and wrap our dispatching code in try except. And the first thing we do, we get path from the request without the slash, or if the path is empty we use main page. And then we look up the action in the request argument. We use request.args.get action, and if it's not given we use show. And then we look up if the action is in the dict, and if it's there we call it with the request and the path. Otherwise we raise not found. And if any HTTP exception happens, we return the error that was catched as response. Now if we go to localhost, we can see hello from main page, and if we access downloads, we can see hello from downloads. Now we can go back to our Python shell and import from wiki.database our page and revision classes, as well as the session, so that we can commit changes. We can create a new page. The page object gets the name as first argument, and a new revision, where the page for this revision is the first argument, the second is the page content, and the third is an optional change node, which we will set to create here. And now we have to commit the changes to the database using session.commit. And we can query all pages and get back a list of the pages. And as you can see, the information we get back is not really interesting because we can't really see what the page is, so we can't see the name. And to fix this, we can implement a wrapper method, which is displayed in the interactive shell so that we can see what the page object actually points to. So we display the type name first, so in this case revision, then the revision ID, and then the name of the page. For revisions and for pages we do the same, just without the revision ID and without the page, of course. So if we go back to the shell now and restart the interpreter, import the stuff again. And if we query for all pages, we get back a nice result where we can see the page name. And the same for the revisions. Also, what you can see here is that the page name is an attribute of the page and not directly the revision. So revision.name is an attribute error, but revision.page.name gives it a page name. This is important for the templates because we will need this information. The text, on the other hand, is part of the revision. Now we can implement our action model. For this we have to go back to our actions file and import from the database model the revision and page object and the sessions object, which is used to commit the session. Then we get the revision ID from the URL parameter as integer. If the URL parameter ref ID is not given or not an integer, it will be none. Then we query the page, the given page. So we query for page equals page name, and we take back the first result and store it as page. Then if the page exists, so it's not none, we check for the revision. So if the revision ID is none, we take back the latest result. And first we have to check that we only get revisions for our current page. So page equals page. Then we get, we order by the descending revision ID. So the higher the revision ID, the newer the page. Otherwise, we just take the revision that is given. And even though we order by revision ID and do not limit the query to one result, we will send a query that is limited to one result because we call first, and first automatically limits the results to one item. And then we render the template show.html and give it the page and the revision. And of course the page name for the case that the page does not exist. Okay, there's an error. It should be session and not database. So we import session instead of database and it should work. Okay, and now we can implement our UTest model. For this we create a new Ginger environment, which is basically the configuration for the template engine, and it's also used as cache for templates. We configure it to use the templates from the current package, and then we implement a render response function which just takes the template and returns a Werkzeug response object with the result from the template render function. And we set the MIME type to text HTML because we want to render HTML. And what's really important here is that the templates are stored by default in the templates folder inside the package. You can change this, but it should be a reasonable default for all projects. So if you try to access the page now without the template created, you will see an exception. So the template show.html was not found by the template engine. So we can create a new folder now called templates inside our wiki package and start implementing the templates there. Because Ginger supports template inheritance, we first create a template called layout.html with the basic HTML structure, which is the doc type and the required title and some navigation elements to switch between show, edit, and log mode. And child templates will then replace these blocks. So the first block here is title, so a child template can change the page title. By default it will show untitled, and of course we have a big headline here which just turns us the title again. So we use self.title and we call this. This will basically render the title block a second time. Then here we have the body and then the navigation links to show, edit, and the log. And now we can create the show template, which extends the layout template and implements the two blocks, title and body. So first we extend layout.html. Then we set the title of the page to the page name, and we escape it using the /e, and it's pipe E filter, which replaces the lower than sign with %LT and semicolon and so forth. And then the body is basically the page text if the page exists, also escaped, and if the page does not exist we display a default error page which just says okay, it does not exist and you can create it if you follow this link. Now if we go back to our browser, we can see the main page. And you can see that the text is actually missing, and the reason for this is that there is a typo. It should be revision.text. And by default, Ginger allows you to access attributes of none or undefined values. You can change this if you want exceptions instead. The edit action is very similar. We also get past the request and the page name, of course. Then we have to query the latest version of the page. For simplicity's sake, we're not implementing editing of older revisions. And then we access, if the page exists, we get the latest revision. If the page does not exist, we will provide an empty revision object, just so that we can push something to the template. We can now copy the show template and store it as edit.html because they are nearly the same. If the page exists, we can show edit page name, and if the page does not exist, we show the create page name, and then we display a simple HTML form with a text area with the page contents and an input form for the change node and a submit button to submit the changes. Now we can register our action in the All Actions dictionary. And then we have to implement what's actually happening if the request was submitted. So we can check if the request method is post. In this case, we check if there is a page. If there was no page so far, we can create it. And then we add a new revision for this page by passing as the page, the text from the request form data, and the change note from the request form data. And if one of these keys is missing, Werkzeug will automatically raise a key error that's also a bad request error, so the user is presented an error page instead. And then we can redirect back to the page where we came from. And for this we need two helper functions from Werkzeug, which is request, redirect, and URL quote. The latter will quote a string for a URL usage. And then we should be able to change the page by adding some more formattings and submit the changes. If you look at the page now, we can see that the wiki formatting is not yet working. So we have to import from Creole parser the Creole to HTML function, which will convert the Creole syntax into nicely rendered HTML. And we just add the property rendered text to our revision and return Creole to HTML from our text. And then we have to go to our template and change the text to rendered text there in our show template so that we see the rendered text instead. And because it's HTML, we drop off the escaping. And of course, it renders nicely. Currently we are returning 200 OK if the page does not exist, which is not so nice, because a search engine will think the page exists even though it's not there. So we can, if the page does not exist, change the response status code to 404 instead. Another thing that's not working so nice is that we are using white space to separate words in the page names, but if we link to another page using Creole parser, it will insert an underline here. But this could be changed if we change the Creole to HTML function to a custom Creole parser with different settings. You can do that on your own. Now the last thing that is missing is implementing the log function. And this is basically a list of all the revisions a page has, so that you can go back and look at an older revision. And for this we just get the page and forward all the revisions to the template. And if the page does not exist, we just raise not found and the user gets an error message instead. So, that's it. Thanks for watching, and you can download the source code for this simple wiki online on the Werkzeug webpage at werkzeug.boku.org/wiki30.